and welcome to Dad's Lab. We're here again with Dad and his rocks, and he's going to tell us about his rocks and minerals. Remember that there are more than 6,000 different kinds of rocks and minerals that we get out of the ground. You find them on the ground, in the playground. You can even find them in the ocean and on the moon. Well, today, Dad is going to tell us why some rocks are different colors. They're very colorful. Look at all of the beautiful colors there. Hi, Dad.
Hi, how are you? Hey, thank you. Welcome to my lab. I want to talk to you today about different minerals, the way you can identify them by different colors, okay? Now, for example, right here is a mineral called lead. Lead is almost always what they call steel gray, okay? That is a characteristic color. And so you can always be sure, and the smell is beautiful too, I love the smell. But steel gray is that. Here's apophyllite. Almost always you find it green. That's the green part. Another mineral is what's white here. But the green cubes in here from India, are green, and that is apophyllite. It is not the only one that's green. There's other green minerals. For example, this one right here is called dioptase, which is kind of rare, pretty kind of valuable, and it's a beautiful green. It makes good jewelry, actually. You don't use apophyllite for jewelry. You use this for jewelry, though, and so that is a green mineral.
What gives it its green color?
Well, in this case, the green comes from chromium. It's one of the elements of the universe, and so chromium is in that and makes it green. Now, here's another one called cuprite or malachite, which is copper, basically. And it's green because it is copper. If you notice the Statue of Liberty, when she was put in initially and cleaned up, she was the color of a new penny. But in about a year or so, she turned green like that. And that's because copper does turn green. And so we that. But not all copper is green. If you find this, that's a blue copper here. See how dark blue that is? And that's a beautiful blue. That's called azurite, and that's a copper mineral as well. Okay, so we'll put these away and maybe move to some other things. Now here's a great piece of feldspar, which is kind of a brownish tan color, and this is kind of typical of feldspar. So that's one characteristic you can use to identify it.
Why is that? What makes it that color, Dad?
Well, I think iron probably is the main reason. The more iron you put in, the darker it gets. And that's illustrated well by this one right here. Now, this is not a very pretty rock, is it? It's a piece of iron out of an iron mine in northern Sweden. And it's very, very magnetic, as you can see. But the dark black, dark gray is characteristic of iron. Not very pretty, but very important. And so we keep a good piece of that. Here is a purple mineral, which is fluorite. Now, not all fluorites are purple. This comes in many different colors, depending on what else is in it besides pure fluorite. But this is what you brush your teeth with. That's the magic ingredient in toothpaste.
Wow, did you cut it into that pretty shape?
Not at all. That's just the way God made it. He made these crystal shapes just like that. Here's another one called calcite, which again comes in many different colors, but it's the characteristic rhombohedral shape of a calcite crystal found in Mexico.
Well, why is that one yellow?
Probably has organic material in it, like things from leaves and things that grew and got mixed in with that mineral. Okay, let's see. Here's one that's pink. Now, I have a good example of quartz. That's right here. That's a perfect color of clear quartz with nothing in it besides just plain quartz. But things do come into the quartz that makes it different colors. And an example of that is this pink quartz, which is that way because of titanium, okay? It's beautiful. It's a state rock of South Dakota, in fact. And this is another quartz, which is called smoky quartz. Can you see why it's made smoky quartz? It's got some things in it, but actually it's got radiation in it. If you take this material right here, this beautiful quartz with nothing in it, and hit it with a lot of radiation, it'll turn like that, or it'll turn like this one right here. This has been under radiation for so long, it's a jet black piece of quartz. So originally it was this color,
Wow.
and it turned into that color, okay?
Wow.
And because of years and years of quartz.
So this is what it should be. That's what it was originally.
Originally, yep.
This one.
Yeah.
And then because of radiation,
Right.
that colored it black over time, many, many years.
That's right.
But it starts off this way and
That's right.
turns black.
And once it's turned black like that, you can't go back to clear. It stays this way, okay? Now, what are some other things I can show you? This is kind of a flaky material. Any of you guys flaky? Probably not. But this is a flaky mineral, and it's called mica, and it comes from Pennsylvania. And it comes off in very thin sheets. So thin that if you look through one sheet, you can see through it, all right? So it's a very thin and kind of useful mineral.
But why is it that color?
It's that color because, again, different minerals that are in it, mixed into it, and probably iron is the big one.
And so that's what makes it gray.
That's what makes it gray.
So today, boys and girls, in Dad's lab, we've explored some rocks of some different colors.
Yeah.
We've seen rocks that were gray, this gray one.
Yeah.
We've seen rocks that were pink, this pink one back here. And rocks that were clear, they have no color at all. Rocks that were almost kind of a brownish black, and then all the way to black. Look at the black one, remember?
Right.
What other colors did we see? We saw purple.
We did.
Hey, look at that beautiful purple one that we saw.
Yeah.
And way back at the beginning in Dad's lab today, he showed us some very unique green colors. Look at the green. There's the copper. Copper that turned green, that's the Statue of Liberty.
Yeah.
There it is. And of course, that bright, bright blue. Look at the different colors of rocks. So today, I hope that you'll go out and look for some rocks. I wonder what different colors you will find today as you go out and on your rock hunt. Okay, have fun. Happy rock hunting. See you next time on Dad's Lab.
Thanks for coming to my lab.